Welcome, gem enthusiasts, rockhounds, and curious minds. Imagine finding a treasure that only exists in one tiny strip of land on Earth. Since its relatively recent discovery, Tanzanite has captivated the world. It's a window into the dynamic forces that shaped our planet, and a thrilling story of discovery, transformation, and meticulous geological detective work. Our tale begins in 1967, in the shadow of Mount Kilimanjaro. One account credits Juman Maro Goma. Initially, the local prospectors hoped for sapphire, a well-known blue gem. Now, blue zoisite might sound a bit, well, clinical for a dazzling gem. Not exactly a catchy slogan for luxury jewelry, right? So, they cleverly renamed it Tanzanite, after its country of origin, Tanzania. Tiffany's original campaign famously advertised that Tanzanite could now be found in two places, in Tanzania and at Tiffany's, cleverly leveraging its rarity. This marketing prowess, combined with the stone's vivid blue-violet color, the unique beauty of Tanzanite is a direct result of incredible geological forces acting over millions of years, approximately 585 million years ago, during the late Neoproterozoic Pan-African orogeny. This dramatic event, included intense heat, reaching temperatures of 800,900 C. The intense pressure and heat remobilized elements like calcium-Ca. Tanzanite is specifically located within these graphite-rich, calc-silicate boudins. The crystallization of Tanzanite occurs in low-pressure tension gashes along these fold hinges and in pressure shadow zones around the boudins. This incredibly specific set of conditions, the precise mix of minerals, geologists consider the chances of another significant Tanzanite deposit being created to be only about 1 in 1 million. So, if you're dreaming of finding this elusive gem, this compact area is the world's only known source and is subdivided into 4 mining blocks. While Block C, managed by Tanzanite, has the deepest shafts, Blocks B and D were traditionally reserved for licensed artisanal miners and still offer the best entry point for new partnerships and responsible exploration. The key to successful Tanzanite prospecting lies in intimately understanding its host rocks and the telltale signs they leave on the surface. Tanzanite crystallizes predominantly within calc-silicate boudins, often described as sausage rocks due to their discontinuous, lens-like shapes, ranging from 10 centimeters to 4 meters thick. These boudins are typically pale green to white and contain visible diopside grains. They are considered the primary growth sites for Tanzanite. Another critical host rock is the graphite plagioclase gneiss, often referred to as the JW zone or horizon. Kyanite graphite gneiss, a dark, platy, aluminous rock, serves as a stratigraphic marker, found above or below the ore. In the field, you'll be looking for specific surface clues. You might also spot graphitic soil anomalies, black, greasy soil with silvery flakes, which indicates underlying graphite gneiss that hosts Tanzanite veins. Another indicator can be gossinous veins, oxidized pyrite calcite strings that yield rusty staining and may cap quartz Tanzanite pockets. Once you find a piece of rough, how do you know it's genuine Tanzanite and not one of its many imposters? In its natural, rough state, Tanzanite is typically a reddish-brown or a brown-green color, affectionately known as diesel color. It's only after heat treatment, usually carried out artificially in a furnace at temperatures between 370 and 390 C for about 30 minutes, rarely, some stones found close to the surface, likely exposed to natural wildfires. One of Tanzanite's most captivating and diagnostic features is its strong trichroism. After heat treatment, it typically becomes dichroic, showing primarily blue and violet. For instance, if you look through the side of a cut stone and rotate it, if a stone appears uniformly blue under all lighting conditions and from all angles, observing a red flash under yellow light is also a notable characteristic of real Tanzanite. While gorgeous, Tanzanite is relatively soft for a gemstone. This property dictates its geological occurrence. You won't find it in alluvial deposits because it would simply get busted. Its relatively high specific gravity of around 3.35 much denser than quartz. It also possesses a perfect cleavage on one plane. When checking for authenticity, beyond the visual cues of pleochroism, look for inclusions. If a stone appears perfectly flawless under magnification, it could be a red flag. In contrast, common imitations like synthetic forsterite have a much higher birefringence. Other imitations like cubic zirconia, synthetic spinel, yttrium aluminum garnet YAG, and glass are singly refractive. Lastly, be wary of cobalt coatings sometimes applied to lower-grade tanzanites to enhance their blue color. Always demand a certificate of authenticity from a reputable dealer. Given tanzanite's unique geological occurrence, confined to specific pockets within metamorphic rocks, mining it is predominantly a hard rock mining operation. This involves going underground into mine shafts and tunnels to extract the gem-bearing rock. The Tanzanian government plays a significant and active role in regulating this industry, having nationalized the mines in 1971 and later dividing the Merelani area into controlled blocks A, B, C, and D to manage production and allocation. Navigating the legal framework is absolutely paramount for anyone involved in Tanzanite mining or trade. The Mining Act 2010 as amended 2017 strictly prohibits prospecting or mining minerals without a valid mineral right. These rights include various types of licenses: a prospecting license PL for exploration, a primary mining license PMTL for small-scale operations, a mining license ML for medium-scale, and a special mining license SMEL for large-scale projects. Additionally, dealer licenses and broker licenses are required for buying, acquiring, selling, or disposing of minerals. The permit application process is rigorous, demanding a cadastral map, a detailed prospecting program, an environmental plan, and proof of financial capacity. For non-residents, special export permits are required, with different fee structures based on the value of the minerals and visa type. For Tanzanite, a specific certificate of origin must accompany every export permit, and for diamonds, a Kimberley process certificate is mandatory. Navigating the legal framework is absolutely paramount for anyone involved in Tanzanite mining or trade. The Mining Act 2010 as amended 2017 strictly prohibits prospecting or mining minerals without a valid mineral right. These rights include various types of licenses: a prospecting license PL for exploration, a primary mining license PMTL for small-scale operations, a mining license ML for medium-scale, and a special mining license SMEL for large-scale projects. Additionally, dealer licenses and broker licenses are required for buying, acquiring, selling, or disposing of minerals. The permit application process is rigorous, demanding a cadastral map, a detailed prospecting program, an environmental plan, and proof of financial capacity. For non-residents, special export permits are required, with different fee structures based on the value of the minerals and visa type. For Tanzanite, a specific certificate of origin must accompany every export permit, and for diamonds, a Kimberley process certificate is mandatory. In a move to spur local economic development and curb illegal trade, they also mandated that large operators, to improve security and prevent smuggling, for anyone serious about mineral exploration, whether for Tanzanite or other precious metals, a systematic and informed approach is crucial. It begins with a comprehensive desk study. It's also vital to overlay prospecting license boundaries using online portals to avoid conflicts. Once the desk work is done, you embark on a reconnaissance traverse. Recording lithological contacts and structural orientations provides critical data. Then comes the physical work: trenching and sampling. Each sample is meticulously bagged, labeled, and photographed in situ, not just for scientific rigor. On-site, portable analyses can provide immediate confirmation. For deeper exploration, core drilling is employed, angling holes to intersect steeply dipping ore zones. Beyond physical excavation, geochemical prospecting offers a powerful, though more technical, approach. The goal is to discover zones that contain comparatively high concentrations of particular trace elements, a geochemical anomaly. For Tanzanite, Soil vanadium chromium Vicar anomalies above 150 ppm are particularly telling. These anomalies can be primary, forming halos around the deposit. Analyzing stream sediments and water for metals removed by weathering can also narrow down promising areas within a drainage basin. Finally, geophysical prospecting combines physics and geology to locate ore deposits. Techniques like resistivity or EM surveys are invaluable for delineating conductive graphite layers. Other methods, broadly applicable in mineral exploration, these advanced tools allow prospectors to see beneath the surface. Always remember that safety, including ventilating trenches and monitoring maintaining daily logbooks for mining commission audits, is not just good practice. As fascinating as the science and adventure of Tanzanite discovery are, it's crucial to remember the human element and the importance of responsible mining and ethical sourcing. This means going beyond mere legal compliance to embrace genuine ethical stewardship. For instance, Tanzanian regulations mandate that 0.3% of an exploration budget be allocated to village water projects. Implementing effective graphite dust suppression is vital to curb respiratory hazards for miners. Furthermore, responsible operations plan for progressive rehabilitation, backfilling pits, replanting native acacia species, supporting genuine companies that adhere to protocols like the Tucson Tanzanite Protocol and uphold labor and human rights laws. And from its incredible birth deep within the Earth's crust, its singular occurrence in a tiny strip of land in Tanzania, standing its unique properties, from its color-shifting pleochroism to its relative softness requiring hard rock mining, the intricate dance of geological formation. So, whether you're dreaming of prospecting for your own piece of this rare blue gem, support ethical sourcing, stay curious about our planet's wonders, and keep exploring.
Welcome to my channel, where you'll find over 2,000 videos on geology, geochemistry, AI, and many other subjects. If you like what you see, help us grow by subscribing, liking, and sharing this channel.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.